Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we'll be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 4 $100 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is MLOps for production level machine learning. Our speaker today is Yochai Atun, who is CEO and co-founder of Converge.io. Yochai, thank you so much for taking the time and joining us today. Really appreciate it.
Yeah, thank you. Thanks for having me.
All right. Well, before you get started, I do want to actually introduce Michael Wade with Red Hat, who's going to just do a quick introduction and let us know a little bit more about the webinar.
Yeah, thanks, Charlene. I just wanted to let the attendees know that, I'm Michael Wade. I'm from Red Hat, and I'm responsible for partner marketing with our software partners who have Red Hat certified software. And Converge.io is one of our more recent software partners who has a certified container and also has a Red Hat certified operator for OpenShift. So we like doing these types of activities with our partners, and that's one of the reasons why Converge is here today.
Excellent. Well, Yochai, I know you have a great webinar, a great presentation on tap, so I'm going to put myself on mute and let you get right into it.
Great. Thank you very much. All right, so in today's webinar, we're going to talk about machine learning infrastructure. Like a lot of the time, we talk about data science and building models and optimizing for data and stuff like that. Sorry, in this webinar, we're going to discuss about the back end, like how do you build an infrastructure that can scale, that will provide you visibility, and you'll be able to build plans on top of the existing stack that you already have. So a quick background about myself. So I'm a co-founder and CEO of Converge. And Converge is a machine learning platform. So we help data scientists to build and deploy machine learning models, like all the way from research to production. I'm a data scientist myself, originally been doing data science and machine learning for a few years, mostly around projects like NLP and speech recognition and deep learning and stuff like that. And during that time, me and my co-founder Leah, she's our CTO, we saw that we need a platform to help us manage our models and experiments in research. And of course, we also noticed that we spend a lot of our time on stuff that don't really relate to data science, like DevOps and IT and what's called today MLOps. So we built Converge, and Converge was an internal product that we used. It was very helpful for us. We saw it can help a lot of other teams as well, so we decided to take it out to production. And this is what we've been doing over the past few years. This is our story. Today, we're working with leading brands from all over the world to help them to build and put models in production. So what we provide in Converge is a few models that help data scientists, IT, and DevOps engineers to put models, to automate models in research and also in production. And the first component is the AI fabric. This is where we're going to spend most of our time today, like having compute resources, orchestration platforms like Kubernetes or OpenShift, and how do you integrate that to your machine learning workflows? Besides that, in Converge, we also have solutions for data management, Data version control is a very important thing in Converge. We also provide a workbench for data scientists, so an easy way for them to train models, to work on their research, to optimize models and algorithms and stuff like that. And last but not least is an easy and intuitive way to deploy models to production. Like one of the biggest challenges today is that a lot of the models don't make it to production because of technical debt that organizations have. So this is one of the problems that we solve. Okay, so the biggest problem today with AI and machine learning at scale is that data scientists are doing very little data science. Like when you look at the data science workflow today and the data science like day-to-day work, a lot of their time is spent on non-data science stuff like configuring hardware, configuring GPUs, CPUs, configuring the platforms, like working with tools like Kubernetes and OpenShift and containers and all that. Hybrid cloud is also becoming incredibly popular with AI. So you need to also you need a way to manage those kind of resources, cross cloud, multi-cloud, hybrid cloud, and like complicated setups. Resource management is a very big problem that data scientists are spending a lot of their time on. For example, having like a GPU server on-prem for a team of 5 data scientists, how do you share the GPUs? How do you allocate the different resources for different projects? That's a big pain and often time wasting for data scientists. And also you have all the machine learning stuff. So data versioning, model management, deployment of models, using open source tools and frameworks, a lot of stuff and very little room left for the actual magic, like building the models, building the the core IP of your technology, building the competitive advantage. And besides the fact that this is like a big frustration for the data scientists, like it's annoying, you know, as a data scientist, I need to worry about all those kind of stuff. This is also impacting the business. Like we see a lot of waste, OpEx waste, a lot of like underutilized clusters on premise specifically, and eventually slower time to market, which is very, very important, especially in AI applications. Now, this is happening because a few reasons, but the main reason that AI today is broken, like development is broken, is there is some sort of like a technical debt. When you look at AI in the enterprise, there are 2 main flows. There is the DevOps flow and what's called today MLOps, which is all about resource management, about the infrastructure, about visualizing the models like in production, integrating to the existing IT stack like Git or Jira or whatever. And on the right, you have the data science workflow, which is data selection, data preparation, model research, running a lot of different experiments, training models, validation of models, tuning models, and eventually model deployment. There are so many steps and components in each of those pipelines, in each of those flows, and those 2 flows are completely disconnected. Like a lot of the time we see different teams managing those different flows. And as a result, we see like a very big technical debt that result in the fact that 85% of the models don't make it to production. And that's big because when you combine those 2 numbers, that a lot of the time of data scientists is spent on like non-data science, and also only like 85% of the models don't make it to production. That's a big problem, and this is what we do at Converge. So today we're going to talk about mostly the infrastructure side of things. So how do you see the enterprise stack in terms of infrastructure and how we see it and how we think it can be built in a way that offers both like intuitive experience for data scientists that are not DevOps engineers, and also provide scalability and high performance for DevOps engineers that manage this kind of stack. So with machine learning, it all starts with the compute. So whether it's GPU clusters, NVIDIA DGX, the new DGX A100, CPU clusters, Spark clusters, also cloud resources. A lot of the time when we talk to enterprises with our customers, we see that there is a pool of resources that is used for building machine learning applications. A lot of the time it's like it's split for different teams, but it's still, you have like desktop with GPUs, DGXs, GPU clusters, A100, CPU clusters, and also cloud. And those create like pool of resources that can be used for model training, for data pre-processing, model serving, inference, and all the machine learning workloads. Like machine learning is very, very compute intensive. So all of those resources are being used for different projects. Now, if we'll try to take like a real example, so often you have like a data set, and then one of the workers is allocated for data pre-processing, and then some workers are allocated for model training, which is in our case ResNet, VGG16, YOLO, Inception v3, Inception v4. Those workers, usually GPU workers, because in this case it's deep learning, those workers are being used for the actual model training. And on the side, you also have some Jupyter notebooks up and running, consuming some compute power, and also deployment and serving, maybe on a cloud instance. So this is like a single pipeline, but of course it can get much more complicated than that. And if we even dive in deeper, like this single pipeline where you have data pre-processing, model training, and deployment, when you dive deeper, it's even bigger, because in each algorithm, you have hyperparameter optimization. So VGG16, it's not just a single run of TensorFlow, it's basically almost 500 runs of TensorFlow code running on the AI infrastructure, meaning that it's going to allocate 500 times the compute resources. And we need a way to, first of all, to make it like possible to run 500 experiments in 500 runs, because when you run more model training with more tweaking, you're probably going to get better results and more optimized accuracy. So we need to be able to allow that when we're building the machine learning infrastructure. And we need also to build a way to make it possible. Like, how do you share resources when you run this kind of like intense workflows? And this is only like a single pipeline. Of course, if you have 10 data scientists, each data scientist has 2 pipelines they manage, then you have 20 pipelines like this managed for a relatively small team of 10 data scientists. All right, now all of those workflows, like we said, are running on my compute infrastructure, and what we provide in Converge, it's basically a platform. It's like a one-stop shop for data scientists and DevOps engineers to run workloads on any of the compute resources that you have in the organization. So you can deploy Converge right here, like the AI workloads, and connect different clusters like Kubernetes, Cloud Kubernetes, bare metal servers, HPC clusters, other schedulers, bare metal servers, whatever you have. And then Converge is just like OpenShift or Kubernetes. We are based on containers, meaning that every job that you run in Converge will run automatically as part of a container. Now, those containers can assign to different compute resources, so GPU, cloud GPU, accelerators, any resource that you have can be connected to the platform. Now, the value of having this kind of setup means that data scientists can just log into the platform or like work on their stuff and distribute jobs on any of the resources that you have available. This is great for data scientists because it's a single experience for all the compute resources. And it's great for DevOps engineers because it's a one unified platform to manage all the different machine learning infrastructure. Now, in reality, a lot of the pipelines that we see, each of them is running on a different compute setup. This is actually a pipeline built in Converge. Like Converge, one of the things that we provide is the ability to design machine learning pipelines, production pipelines that can run on your infrastructure or in the cloud. And in this case, we're doing a classic machine learning pipeline where you load data, you then do like pre-processing using Spark in an on-prem Hadoop cluster, and then you do model training using GPUs. So GPU on-prem that you have with cloud bursting enabled. So we also support distributed training with PyTorch and TensorFlow. So this could also be great and useful. There are several use cases also loading data, doing some sort of like benchmarking, compressing the model and deploying the model in the cloud. This is another pipeline example where you do the model training on premise, and then the deployment, which is supporting also Canary deployment, just like in software, but for AI. You can deploy models to the cloud and do some A/B testing and stuff like that. Now, we are now going to discuss about how you can design, how you should design your own machine learning infrastructure. Like how do you, what should be the architecture of this kind of setup? What kind of workloads you need to be able to support? How do you need to interact with your data scientists or DevOps engineers and build a platform that's ready to scale? All right, so the number one decision, even when we started building Converge, it was to use containers. Like containers is in software, it's pretty much like the default way now today to deploy software. In machine learning, it's even better. Like a lot of the a lot of the trainings and a lot of the serving and it's like the design of running containers, it's like it was built for this kind of use case. You can define environments, which is great also for reproducibility and reproducible data science. You can launch the containers anywhere on any cloud native technology. So on-premise, Kubernetes cluster, bare metal, using Docker simply, and also cloud resources that have extensive support to all the different containers. And of course, platforms like orchestration platforms like OpenShift that make it easier for you to run and execute containers in the cluster. So when you're now building, let's say you get assigned with a task to build the infrastructure for your data science team members. So sorry, the first thing is, again, containers. Second thing is compute resource agnostic. And this means that even though Kubernetes is becoming like the standard way of deploying stuff and for orchestration platform, there are still so many flavors of Kubernetes. There is Rancher, there is OpenShift, there is vanilla Kubernetes, there is even for like small deployment, there is micro KA, there is Minikube. There are so many different Kubernetes options. So when you're designing your own infrastructure, you need to think of what is the orchestration platform that you're aiming to support. And maybe you need also to think long term, like maybe you're starting today with X and you need to migrate to Y or stuff like that. So you need to be able to design the stack in a way that that fits your existing infrastructure. Second thing is what like machine learning is new, and usually it's new in the enterprise. Also, Kubernetes is quite new in the enterprise. So whatever infrastructure that you're designing, you need to be able to leverage leverage all the compute resources that you already have in your enterprise. So if you have like a large Spark cluster, Hadoop environment, or if you have like bare metal servers that are not running Kubernetes, like large CPU clusters, then you need to be able to support those as well, because it's not like that the IT will replace all the big data Hadoop clusters in a single day, even though that we of course recommend running now today's Spark on Kubernetes and all those kind of stuff. It's still going to take time. So to increase adoption of your data scientists and to make it easier for them to consume those kind of infrastructure, that kind of you need to build to build for that. Like you need to build a platform that can integrate to the Hadoop cluster, that can leverage Spark, that can leverage Yarn, can leverage all the technology that your organization has. Now, hybrid cloud is a big topic and worth like a webinar on its own. But in our case, in machine learning, again, it's great because usually machine learning workloads are stateless, meaning that I can now run a machine learning training for a day, for 2 weeks, whatever, and then I can just terminate the machine. Like as long as I'm storing all the models and all the data, I can simply terminate the machine and just forget about it. And this means that for hybrid cloud deployment, unlike software where you need to persist stuff and to make sure that database is shared across the different hybrid environments, in our case, it's extremely useful because I can now, let's say I have 8 GPUs on-prem and I have 10 data scientists. So I want to be able to utilize all of the 8 GPUs, and only when I get to 100% utilization or allocation, only then burst to the cloud. And in Converge, we have that, like we have this cloud bursting capability, and it's amazing because customers are, first of all, increasing on-prem utilization, of course, and also reducing cloud costs, and also data scientists get to to easily scale machine learning activities. Now, the other bullet, like flexibility and being able to easily extend the platform, is critical because machine learning is evolving extremely fast, and MLOps even faster today. So you need to design the platform in a way that you'll be able to easily extend it, meaning that if there is a new technology, a new operator, a new platform that you want to integrate, you need to be able to do that. And so it's very, very important that the technologies that you pick today to build your infrastructure are scalable, like they can be extended and can be flexible. Now, another very important thing that in Converge we have like a product design process that fits exactly this bullet. But when you're building a machine learning platform or building the infrastructure for a machine learning platform, you need to be able to provide a simple interface for data scientists. Remember, they're not DevOps engineers, they're not IT. They're usually, a lot of the time, they are PhDs in math, and they don't really want to work with YAML files or namespaces or deployments or whatever. They just want to work on their models. So you need somehow to be able to abstract the interface for a data scientist, especially if you're using Kubernetes. And but you also need to be able to provide them with all the flexibility and control that they need. Meaning that if there is, let's say, like a hardcore data scientist that want to get into the internals of Kubernetes, you need to be able to allow them. Also, for your sake, like a lot of the time, DevOps will need to dive deeper. So you need to have some sort of like, you need to have that open for both you, like DevOps engineer and data scientist. Now, the last bullet, we like to call it a reality check. A lot of the time we see teams build infrastructure or machine learning platforms that are not a good fit for the data scientist. So if your data scientist is working on analytics problem, that you shouldn't be getting inspired from computer vision or deep learning based platforms. You need to really tailor the platform to the data scientist. Okay. Okay, so in Converge, what we provide in Converge, we like to call it an AI OS. It's like operating system for building AI. So you basically deploy Converge on any cluster. It could be OpenShift or Kubernetes or whatever. We even have the OpenShift operator that you can use. And with like a single script or single click, you can deploy Converge. And then you get everything you need to build and deploy models at scale with the best production ready platform, like MLOps platform. So we provide all the things that we talked here. We provide with Converge is container based. You can integrate to existing schedulers, whether it's like Spark or other clusters that you have. You can integrate cloud clusters as well. You can integrate multiple clusters like GPU servers, CPU servers, accelerators, everything you need. And it's very intuitive and user friendly. So data scientists are can build their stuff really fast, and you can get to production from research like in the fastest way possible. Now, when we build the infrastructure of Converge, so as you can see, you can add multiple clusters to Converge, and then you get like a pool of resources, and those resources can be consumed by data scientists. Now, this could be like complicated because when you want, let's say you have Spark, you have also Kubernetes, and you also have bare metal servers connected to the platform. So how do you schedule jobs on each of the different interfaces? So in Converge, what we built, we like to call it like a meta scheduler, meaning that data scientists can run a job. It could be whatever they want because Converge is containerized. And then they submit the job to Converge. It runs through some sort of like a translation, we like to call it. So it gets an input, the job that the user specified and the provider. So Is it Kubernetes? Is it Spark? Is it OpenShift? And then it outputs like the list of commands that needs to be executed on each of the different providers and run it. And then this is how we abstract, basically make it incredibly simple for DevOps to connect all the different resources and for data scientists to run any workload from the same interface. Now, just to give you some real life examples from customers. So the Converge application is deployed on-prem in this case, and then multiple workers are connected. Each CPU worker is like 100 cores, 120 cores, and we also have DGX, NVIDIA DGX Kubernetes cluster connected, training clusters, production clusters, Spark, Hadoop, like legacy Hadoop environment, and AWS. And all of those connected are connected to Converge applications. So data scientists can run workloads, CPU workloads, GPU workloads, cloud workloads, Spark workloads in a single click from the same environment. And it's great also for IT because this DGX is much more utilized now when it's connected to Converge. Another nice example is this. So this is like a hybrid multi-cloud environment. So Converge app connected to DGX1 and another DGX1, both are on premise. Those used to serve two different teams. Today, they get like a pool of 16 GPUs that are can be consumed by anyone on the team. It's fluid. And also they have connected their cloud resources. So AWS and GCP, both of them are connected. So it's great for them because they can, like we said before, they can really increase on-prem utilization and then burst to AWS and GCP only when they really need it. And they can even prioritize the cloud bursting. So first burst on GCP and then burst on AWS. You can also integrate Spot or preemptible instances, so it can save a lot of money. Another nice use case is a customer that has multiple DGXs, DGX1, DGX stations. So here in the on-premise side of things, it needs to we need to see that this use case, basically they started from a single DGX1 and then they bought another DGX station and another one and another one. So Converge helped them to scale very easily. So if there is through the platform, they can see the utilization, see the resources that are being used. And based on that, they can decide, do I need to buy another DGX? And if so, what kind of DGX? And with Converge, we made it incredibly simple for the IT to be able to forecast how much compute they need to buy. Also, Converge here in this case connected to Azure. So again, to avoid block for data scientists, so they don't need to face like a problem of I don't have any GPU to run my workload on. Converge will automatically burst to the cloud. Okay, so those were a few like example of like real life machine learning infrastructure architectures. So it's great to see like how companies are doing that in reality. You would think that those like maybe a little bit complex, but this is often the case. Like a lot of the time you already have compute, you already have CPUs, you already have GPUs, and then you just want to connect also your cloud. So Converge makes it easier. So when you are building your own machine learning MLOps platform, make sure that you can support this kind of stacks. Okay, next I want to talk about visibility, and this is like really, really important because when you have this kind of setup, you need to understand what's going on last week, what's going on now, what's will be going on next week, and to do so, we recommend you to track everything. So when you talk about machine learning tracking, usually you would talk about experiment tracking and model management. In this case, we're not going to talk about that. Like that's also very, very important. But in our case, we're going to talk about tracking the infrastructure. So you need to track the job metadata, like what container, how much resources did the data scientist request. Also, maybe like a list of dependencies or network configurations or data or storage configurations. Also job logs, like what happened in the pod or in the container when the data scientist ran this job. System metrics, how many or how much of the GPU is really utilized, like is really consumed by the user. And also again, like machine learning metrics and artifacts, so model weights, checkpoints, and all those kind of stuff. Now, in Converge, we focus on three key metrics. One is the total capacity. So how many GPUs do I have connected in my cluster? And that's the total capacity, the number of GPUs that are available in total. Then the allocation. So out of the, let's say, 8 GPUs that I have, I'm now allocating 2 for this specific job. So the allocation is 2 GPUs. And out of the 2 GPUs that I have allocated, I'm utilizing 50%. So out of the 2 GPUs, 50% is utilized. So I could have probably used just a single GPU and get the same performance. So those metrics are very, very important. It's going to provide you and also your data scientists with like much better infrastructure visibility. You'll be able to see really everything. Now, there are many, many open source tools that you can use, free tools that you can use to build this kind of knowledge. Grafana, Prometheus, ELK, of course, and many others. Now, in Converge, we provide like 360 view of every job that you run. So you execute a job, and we collect the job metadata. And when the job is in an ongoing state, we track the logs using Elastic. We track the system metrics using Prometheus, and we collect also machine learning metrics and the file system. And with this, we can really see everything. Like I can get 100% visibility to what's going on now in my cluster, what happened last week with my cluster, and also maybe to be able to predict the future. And we provide some nice visuals in the product, like we call it the machine learning infrastructure dashboard, a place where you can track those 3 key metrics that I talked about. So 16 GPUs in total, 8 are allocated, and only, let's say, 50% are utilized. So we track the waste, the capacity waste, and with this knowledge, I can maybe educate my data scientists like how they should be using the GPUs. I can maybe stop jobs that are stuck or weren't using any of the resources that they've allocated, or maybe data scientists like also forget sometimes to shut down a Jupyter notebook or something like that. But from here, because you get this kind of monitoring and visibility, you can do that very, very easily. Now, besides providing some nice insights out of the box, we also provide the raw data because, you know, we are data scientists ourselves, and data, we know how data is important. Data is like, it's like gold. In our case, the data that represents all the jobs is stored and can be exported very, very easily. So here I can see all the jobs that are running in the platform, and I can see the utilization of the GPU, the CPU, the memory. I can see the project and the user. So maybe I can search all the users, all the jobs that were created by myself, and I can learn. Maybe I'm not utilizing all my GPU or all my CPU, so maybe I need to use a different compute resources. I can maybe also build like a report of how much of the models are used in the cloud, and track some really nice stuff. Now, when you're building, like when we were starting to talk about like insights from the machine learning infrastructure, of course, it depends on your environment, like and on your use case. If you have GPUs, if you don't have GPUs, if you're doing mostly deep learning stuff, or maybe you're doing mostly analytics. So you need to define the key questions. You need to define what kind of information is important for you and maybe stakeholders, so they can you can decide maybe like about the future of your machine learning infrastructure. So maybe some key questions that we like to think about. So what users are not utilizing all their hardware resources? Maybe there is like a pattern of users that are wasting GPUs. Second question is about like, should we buy more GPUs? And if so, how many? Because let's say I got 80% utilization this month, and last month as well, and the one before I got only 50%. Like the average previous quarter was around 50-40%. So there is like like an increase in demand for GPU, and the utilization is working well. So maybe it's time to buy more. Also, maybe it's a software issue. So what kind of containers are not utilizing the GPUs? Maybe creating some chargebacks report, like usage based on users, projects, teams, whatever you want. And for more advanced insights, maybe some recommendation and stuff like that. And this is really where we see the future of Converge, and what we're going to release like next year, early next year, is something that we call intelligent scheduling. So instead that the data scientists will need to define how many GPUs they need or how much CPU, then we will be able to automatically recommend them with decisions like, based on previous runs, this you should use 2 GPUs to run this, or even with hyperparameters. So this is sort of like a meta learning, like based on previous runs, you should increase the batch size because the GPU memory was very, very low. So maybe increasing the batch size would help to utilize the GPU better. And there are so many things you can do about this that having the data, even the raw data, can provide a lot of value. So this is why all the data in Converge can be very easily exported and used for any kind of use case like this. Yeah, so this was the last slide. I want to show you a quick demo of Converge and how it works in action. But if you guys have any questions, then feel free to ask.
We actually, Yohai, we actually do have some questions here. I was holding off. You want me to bring a couple of them up now, or you want to wait till after the demo?
Sure. Yeah, happy to.
Mike, let's see. Most applications being built are what we call in Forrester AI infused apps. So you'll have traditional software and models coexisting in the same AIIA. Today, though, data scientists and software developers will have their own separate life cycle and separate tools and pipelines. Do you see any convergence of DevOps for software and DevOps for AI converge in one platform and one integrated AI development lifecycle?
Yeah, so that's a really, really good question. And this is a question that we debate a lot of, internally in Converge, because the way we talk about Converge is that Converge is like CI/CD platform for machine learning. And I think in one day, maybe the two fields like DevOps and MLOps would converge to a single platform, but it's going to take a lot of time. And today, those two pipelines, like CI/CD for software and CI/CD for data science, are very different. And in data science, you need to worry about data. It's a lot of the time, it's very large scale data, and you need to version the data, and you need to version the models, and you need to version the results and the hyperparameters, and also machine learning is very research oriented. So you need to have, even if you have automated like pipelines, CI/CD for ML, then you need still a way to be able to track the results and to continue research also when it is in production. So I do think in one day they're going to converge, and there are some things that are very similar, but not.
There was a lot of really good comments coming in here about how useful, but here's another question. What are exactly epochs?
Yeah, so epochs is basically, it's a hyperparameter. It's the number of times you want the algorithm, the deep learning algorithm, to go through the data that you have fed into the algorithm.
Okay, we have a couple more questions, but why don't we move on to your demo, and then we'll get to those questions right after the demo.
Sure. Okay, so this is Converge. You can really think of a Converge like the question, it's sort of like Git designed for data science. It makes the entire data science workflow accessible, reproducible, organized, and managed. You can finally share your models, your research, your experiments, and get everyone on the same page. Now, before we jump to one of the projects, I want to show you the compute. So this is what we discussed before. You can attach any kind of cluster to Converge, on-prem, cloud, Spark, anything. And then you get like a dashboard where you can track all the capacity and utilization and see all the jobs that are currently running. And you can filter, of course, and you can export this data, and you can see it per CPU, per GPU, or per memory, and also per cluster. And in any point in time, you can see what is running now with what kind of what users and what projects. So this is very, very useful. Also, Converge, like we said, Converge runs with containers. So we provide a lot of pre-built containers out of the box. And you can also connect any kind of existing registry that you have. So even though MLOps and DevOps tools are currently separated, it's very important to build your platform in a way that you can very easily integrate it to the existing IT stack. So if you have like Jenkins or stuff like that, you need to be able to integrate. Now, inside a project in Converge, you can there are a lot of ways you can build models. You can launch a workspace, launch VS Code, Jupyter Notebook on any kind of compute resource that you have, on-prem or cloud. You can choose any Docker container, and once you click Start, Converge will automatically spin up a container, spin up a resource, allocate the resource for your workload. It will pull the container, pull the code. install any additional dependencies, and the data scientist will have a working environment up and running in a few seconds instead of a few hours of configuration. Now, we also, in Converge, we provide flows, which is an easy way for data scientists to build advanced pipelines of machine learning. So both data pre-processing, model training, model selection, hyperparameter optimization, model deployment to Kubernetes, everything can be in a single pipeline, multi-steps, designed to scale, and with like hyperparameter and optimization built in. This can also be represented as YAML, as just like regular DevOps platforms. And whenever I execute this, so you see this is going to run 49 experiments on on-prem compute and cloud compute, and eventually deploy the model to the cloud. And each run is automatically tracked, and tracked not like the DevOps CI/CD pipelines, tracked in a machine learning way. So we track all of the hyperparameters, all of the metrics, metadata, data version. We even create plots that you can understand how your model is performing, and maybe you can stop it. We show you also all the logs of the models very easily, so you can see like, let's say what was the epoch that was used. You can also see all the artifacts, and get like a database of all the different models that you built. Now you can even select a few experiments and click compare, and then you get to see all the different models side by side with exactly what happened in each model. This is really great for research and also for production, because a lot of the time you train a lot of models. With this, you'll be able to see for every model that you had or have in production exactly how it was trained, with what kind of metadata, hyperparameters, metrics, everything is collected, so you can reproduce everything. We also provide data scientists with the ability to deploy models as APIs. So in a single click, you can deploy a model on your Kubernetes cluster. And besides the DevOps automation that we have here, we also provide data scientists with like an X-ray to the model. You can see all the input of the model and all the output, so you can detect model decay or maybe data drift or stuff that can perform, that can impact your model performance. So this is also very useful. And this is really what Converge is all about, like a platform for easily running machine learning workloads on any kind of compute, with end-to-end capabilities like data management, model management, CI/CD pipelines for machine learning. We like to call it continuous training and continuous deployment, and have everything, all the data science team on the same page. So yeah, this was a very fast overview of Converge. Any other questions?
Yeah, there was another one that came in a little while ago. I missed it. Maybe it was already covered. I'm not sure, but we can readdress. This one came in from India. My question for Yohei is how to use data-driven ML infrastructure and capacity planning. Thanks in advance.
Yeah, so that's a great question. So this is also what we discussed before. With the Converge dashboard, you can build really advanced capacity planning stuff, because we collect all the data. So let me just give you an example of what you can do with this. I can now copy the data right here, and I can just open a spreadsheet. In our case, it's just Google Sheets or something. And I can use the command import data and the URL. And now it's basically going to pull all of this data into a spreadsheet. that I can simply analyze. Like I can now insert a chart that I want to see based on a project. Like I want to see usage based on project. So I can do E. So you see now I can see that Clara project is the one that consumes most of the GPUs. And I can do the same based on users. So let's say L, like who is the most active user? So I'm second in place. I need to work on my stuff. But I can see that this is maybe unproportional. Maybe I need to investigate and see, and maybe they're not utilizing resources well. Maybe they're spinning up and not spinning down resources. And I can build very nice stuff and even build some forecasting based on this. Like we said before, split it to quarters and see the utilization per quarter and see if it increases or decreases. And based on that, to plan future capacity and stuff like that.
That was
All right.
really, I was going to say, go ahead, Charlene.
No, I was just going to say that's pretty amazing stuff. Unfortunately, we are 4 minutes to the top of the hour, so I'm not sure that we've gotten any other questions in, but let me just do a quick. Yeah, it doesn't look like we've gotten any in, but boy, you have a lot of admirers, I will say. I've gotten a lot of positive comments on today's presentation in the questions box. So thank you to everybody who did submit questions and comments. Yochai will be getting a copy of all of the questions that came in and the comments. So if we didn't get your question answered for whatever reason, please know that he will be able to, I'm sure, or someone from his organization will be able to follow up with you offline to get your question answered. Also want to remind the audience quickly that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website. So you can always go look for it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, I did mention at the top of the hour that we would be doing a drawing for 4 $100 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is James C. Congratulations, James. Our second winner today, Chris K. Congratulations, Chris. Third winner today is Ramesh K. Congratulations, Ramesh. And final winner today is Monica R. Congratulations. Somebody from our organization will be following up with you offline via email to get your gift card over to you. So please check your inbox. If you don't see anything in your inbox, please check your spam folder. Yochai, thank you for a great presentation today. Really, really good stuff. I really enjoyed watching, especially watching the demo. That's good stuff. And I know the audience got a lot out of it also. So thanks again. Appreciate it.
Thank you very much.
Michael, any last words?
Nope. Just that we will be reaching out and getting the $100 Amazon gift cards off to the winners, and we'll be taking care of that later on this afternoon.
Perfect. All right, great. Well, this is Charlene O'Hanlon, and I am now signing off. Have a great weekend, everybody, and please stay safe.